doing section 2.6 on related rates. So when we were working in section 2.5, I taught you guys how to do implicit differentiation. And every time you took the derivative of y, you remember how you had to tack on a dy dx at the end? Remember, okay, dy dx, we tacked on a dy dx at the end because we were finding the derivative of y, but we were supposed to be finding the derivative of x's. So it was the derivative of y in terms of x. We're going to do exactly the same thing today, except today we're going to be finding the derivative of a bunch of different things, but we're going to find them all in relationship to or with respect to time instead of with respect to x or some other variable. So everything we do today is going to be something dx or dy or dA or d something over dt. So no longer are we going to have a dx on the bottom, we're going to have a dt. And tomorrow we're actually going to put this to use, like put it in terms of actual real problems. So today we're just going to talk about the math. So we just need to get the concept down today, and tomorrow we will put it to work. So, all right. So when you are finding the rate of something, the rate at which something is happening, you are trying to figure out, or you are figuring out how fast it's happening. I hope you would agree with that. So you are trying to figure out how fast something is happening in terms of time. So when you are working through these problems today, you are going to differentiate with respect to time. You're going to differentiate with respect to time. So, an example. Can I go to a new page, you guys?
Yes.
All right, an example. Y equals x squared plus 3. And what I want you to do is figure out how fast is the y changing with respect to time. So what I want you to do is find dy dt. But when you work through this, you're going to realize that you can't figure out how fast y is changing with respect to time unless you know some other pieces of information too. So some other things that you need to know in this problem is you need to know that the x value is something. So in other words, what I'm asking you to do is figure out how fast is the y changing at a value of 1 on your graph when the x value is 1. But I also have to tell you how fast, there's going to be two unknown pieces if I don't give you more information. So I also have to tell you how fast is the x value changing with respect to time. So I'm going to tell you that dx dt is 2. And now you're going to apply the same rules that you have been applying. We're talking about related rates. We're talking about how fast something is changing with respect to time. So when you find the derivative of, say, a y value, you are going to find the derivative of y, which is, what's the derivative of y?
dy.
It's 1 times dy d, but not dy dx. It's going to be 1 times dy dt. We are finding it with respect to time. Is equal to, what about x squared? What is the derivative of x squared?
2x.
It is 2x. But again, we have to do this with respect to time. So we have to multiply that by dx dt. And then, of course, what is the derivative of 3?
0.
It's 0. All right? Our job is to figure out, remember we're trying to figure out what is dy dt. How fast is the y value changing? So when I do this, I have to have solved for dy dt. Am I set up right now to solve for dy dt?
Yes.
1 times dy dt is dy dt. So I really have dy dt here is equal to 2 times x dx dt. Can I figure out dy dt? Yeah, because dy dt is 2 times x, and I know that my x value is 1, and I know that dx dt is 2. So how quickly is my y value changing?
4.
It's changing at 4. 4 whatever. It might be 4 feet per second. It might be 4 miles per hour. I don't know. We don't know what it is, but we know that it is changing at a rate of 4 something. Yes.
Is it gonna tell us like that information you
Yep.
put on the side?
Yep.
Oh, okay.
Yep, I will always give you that kind of information. And tomorrow when we start putting it to use, you're going to have to figure, you're going to be given this information, but you have to figure out of the pieces of information, which one is the x and which one is the dx dt. But I don't think it's going to be a huge deal, okay? Yeah. All right, I have one more example. Yeah. Do one more example, and then we will, and that's it. You guys, that's all there is to this. It's not horrible. All right, one more example. Y equals 5x squared plus 3x. So very similar to the last one, but this time what I would like you to do is find dx dt. So I'm finding how fast is the x value changing rather than the y value. But I'm going to give you some information. I'm going to tell you that x is equal to 2. Was it equal to 2 last time too?
No, it's equal to 1.
Okay, it was equal to 1. Okay. And I'm also going to tell you that when the x value is 2, the y value is changing at 8. It's equal to 8. All right, so we have to differentiate this now. Y. What is the derivative of y? Yeah, it's okay if I don't write down 1.
Yes.
Okay, all right. dy dt is equal to, what's the derivative of 5x squared? It's 10x dx dt. Very nice, you guys, very nice. Plus 3 dx dt. All right, what are we trying to find? We're trying to find dx dt, and right now there's a couple of dx dt's going on there. So what we're going to need to do is factor out a dx dt. So I have dy dt is equal to 10x plus 3 dx dt. Are you okay with what I just did?
Yes.
What did you say? Alright, I'm trying to solve for dx dt, so I'm going to divide by 10x plus 3. Those cancel out. I have to divide the left side by 10x plus 3. So to figure out what dx dt is, how quickly is the x value changing? dy dt is what? 8. So I have 8 divided by 10 times the x value. Well, my x value is 2, so I have 10 times 2 is 20 plus 3 is 23. So I have 8 over 23 is equal to dx dt. So it's changing at a rate of 8/23, whatever. Questions? It's not horrible, is it?
Are they arguing y equals or is it gonna be times?
It's always going to be y equals. Always, I hate the word always. I would say, no, not necessarily. I'm trying to think today. I couldn't even tell you if that's true today or not. Yeah. But if it's not, you still differentiate the same way. You know, there might be a product rule in the middle of it or whatever. But okay. Hey guys. guys, let me tell you, I gotta say one more thing. When we were working through this, you needed to replace this x value right here with whatever x was. X was what, a 2? We had to put a 2 in there to get an answer. There might be times when there's a y in here, and you don't know what y is. You only know what the x value is. What are you gonna do? If you need the y, but you don't have it,
Solve for it.
how are you gonna solve for it?
Divided by.
The original.
What'd you say?
Is it the original?
Go back up here. You have the x value, but you need the y value. You understand what I'm saying? If you need the y value, you're going to go in here and you're going to replace these two x's with whatever the x is, and you'll have your y value. So just keep that in mind. If you need something that you don't have, there might be a way to find it quickly. All right. I'm done, unless you guys have anything you want to ask.